Good morning, my dear students. As we all are facing crisis situation of coronavirus, I request you all to stay at home and stay healthy. Due to this locking period, we are starting online classes. I hope it will help you a lot. Before starting, students, kindly go through the highlighted portion that will match with my voice. Now let's start with the topic acid, bases and salts. Under this acid, bases and salts, three terms are there. First term is acid. According to the science, or you can say according to your chemistry, acids are those which are furnishing H positive ions. Kindly check the highlighted portion which are regarding the acids. With the bases, they are furnishing O2 negative ions and OH negative ions. Third one are the salts. Salts are the chemical compounds which are formed by reacting acid and bases. Means when acid and bases are being reacted, then salts are formed. Now the next term, that are the indicators. Indicators are the identifying things or substances which are used to test acid and bases. Different types of the indicators are there. First, we are studying the natural indicators. Under the natural indicator, two indicators are there. One is the litmus and second is the red cabbage extract we are using in this one, and we are generally calling red cabbage test. First, I am starting with the litmus. Litmus is a natural indicator with the color of the purple dye. It comes from the lichen plant. Normally in the bio you are studying the lichen plant. If your solution is neutral, then the color of that will show purple. And if it is pouring under the acidic solution, then it comes the red, and with the basing solution it gives the blue color. It means three colors are being given by the litmus: purple with the neutral solution, red in the acidic solution, and blue in the basic solution. Next indicator is your red cabbage indicator, again categorized under natural indicator, which remains red in the acidic solution but turns its color to the green in basic solution. By these difference in the colors, we can identify whether it is your acid or base. Coming to the next type, that is your olfactory indicator. What are the olfactory indicators? Olfactory indicators are based or identified by their smell or odor. Kindly check the highlighted portion by the smell and odor. For that we are using example onion, vanilla and clove oil. With the onion, if we are identifying or we are taking for the testing of the onion in the acidic and basic solution, onion having a peculiar odor or the smell is there. In case of the acidic solution, if the acidic solution is there, the onion smell will not destroy. But if it will be the basic, then its particular smell will not be identified. It means again to identify whether the substance or the solution is acidic or basic, we are using a olfactory indicator, that is onion. Now the detailed study of the acids which having a sour taste. This table is a table which is leading or dealing with your naturally occurring acids and named as organic acids. Organic acids means it is coming from the organic matter. Different examples are there and mark it important, and you have to learn these compositions with their examples. For the acids, if we study the chemically, under the acids, one thing we have to study that H positive ion, at the starting I told you that the hydrogen ion is present in all the acids. For that, if hydrogen ions are present, then what is the purpose of this hydronium ion? H positive ions can't exist independently. It will only be survive when it combines with the water and forms the hydronium ion. It means the hydronium ion is essential for showing the acid property. Check the example of HCl. HCl react with the water and there is a formation of hydronium ion and chloride ion in the first phase. Sulfuric acid react with the water, there is a formation of the hydronium ion again. Check the third example. In third example also the hydronium ion and nitrate ions are forming. In the fourth example, hydronium ion and acetate ions are forming. It means that in every case, if the hydronium ions are coming, then only it will show the property of the acid. Now the details, how these hydronium ions are forming. As previously I told you what was the reaction. Now chemically I am showing this reaction. When H positive ion react with the water, check it, there is a formation of a hydronium ion. H positive ion react with the water, there is a formation of hydronium ion, and these hydronium ions are showing the property of acidity. It means the hydronium ions are responsible for the property of acidity. Now the classification of the acids. For the classification, the different base classifications are there. First classification is based on the sources. Different sources are there on the basis of which we are classifying the acids. First is the organic acid and second is inorganic acids. Organic acids are those which are coming from the plants, means from the plants or the plant composition. These are normally the weak acids and don't ionize completely in solution. Why? Because they contain both ions and molecules. Inorganic acids, mostly coming from the minerals. Example is the hydrochloric acid, sulfuric acid, nitric acid, and they are strong acids and they are ionizing completely in the solution. For the second part of the classification, that is based on their strength. Strength, what the meaning of the strength is there? Strength means the concentration of the hydronium ions which are being produced in aqueous solution, because hydronium ions are responsible for the acidity. More the hydronium ions, more is its strength. For that again the different categories are there. First is strong acid and second is your weak acid. Strong acid, they ionize vigorously in aqueous solution. They having a high concentration of the hydronium ion. Weak acids, they are partially ionized, means the hydronium ions are not being formed at the higher concentration. Some are ions, some are molecules, that's why they are weak acids. For the example of the strong acid, first is your hydrochloric acid, and for the weak, that is your acetic acid or carbonic acid is there. Now, another very important formula which is showing the degree of ionization. It means that number of acid molecule ionized from the total number of the acid molecule into 100. That is a degree denoted by the alpha, and that shows the strength of the hydronium ion. And if its degree is greater than 30%, then it is a stronger acid, and if it is lesser than the 30%, then it is a weaker acid. It means the base is your what? The formula. Based on that formula, if the degree is coming the more than 30%, then it categorized under the stronger acid, and if it is categorized under the lesser than the 30%, then it will be your weaker acid. Now the third categorized form or the classification is based on their concentration. Concentration means that how much amount of acid is present in the aqueous solution. How much amount we are adding in an aqueous solution, that is the concentration. If very small amount of water is added or no water is added, then it is concentrated. And if more and more amount of the water is added of its own mass, then it is dilute acid. Concentration is generally showing the amount of water present in an acid. One thing very important, the dilute as HCl is stronger than highly concentrated acetic acid. The reason behind is the concentration of hydronium ions, which are being more and more in case of HCl. Next part which we have to study under the classification of your acid, that is your molecular composition. Fourth classification is based on the molecular composition. In that, the first acid are the oxyacids. Oxyacids having in their composition oxygen. Check the examples. In every part, the oxygen is present, whether it is nitric acid or sulfuric acid or phosphoric acid or acetic acid. All are having oxygen along with hydrogen. Hydroacids, which had the hydrogen in their composition, and no oxygen is present. Check it again. Hydroacid, under that the example hydrochloric acid, hydrobromic acid, hydroiodic acid is there. Next classification is based on their basic T. Basic T again showing the different your ionization property. It is based on the basic T is your ionization of one molecule of an acid in an aqueous solution, again based on hydronium ion. In that, if we are studying the different types of again the categorization, the first your type is your monobasic, which is giving only one hydronium ion. In that part, only one hydronium ion is being furnished. Check the example, HCl is furnishing hydronium ion and chloride ion. Acetic acid, again showing you what? Your monobasic in nature because of the presence of the one hydronium ion and acetate ions, and these acetate ions are not furnishing afterward. Next type is your dibasic, which are furnishing two hydronium ions. Example, sulfuric acid, oxalic acid, sulfurous acid, carbonic acid. Di, if we are doing the detailed study of the dibasic, under the tribasic acid, one is your what? One is your normal salt and two are your acid salts. In tribasic acid, two acid salts are forming and one normal salt. Check it. The first example, when we are taking the phosphoric acid, first there is a formation of the monosodium dihydrogen phosphate. In second, again hydrogen is present in the example and there is a formation of the disodium hydrogen phosphate. In the third one, there is a formation of the trisodium phosphate. In the first two examples, here H2 is present, here only H is present and there no H is present. It means in the three step is forming, first two equations are your what? Acidic salts and third equation is forming your normal salt. Salicylic acid, that is H4SiO4, has the basic P of 4. Only one example with your basic P 4 is there, that is salicylic acid. Now the next we are proceeding to the preparation of your acid estate. First is the synthesis. How the synthesis? It means that direct there is a combination or reaction is going on. Hydrogen reacts with the chlorine in the first reaction. In the second reaction, bromine. In the third reaction, sulfur. Forming HCl, HBr and H2SO. Directly there is a formation of acid. Second example, second type, in which the acidic oxides dissolved in water to give the acid. Acidic oxide examples are your sulfides, sulfur dioxide, carbon dioxide, and your phosphorus pentoxide is there. All are forming the your what acid, different types of the acid, but the reaction is with the water. Next we are coming again with the next type, how the process of your formation is going on. That is third, that is oxidation of non-metals. When the non-metal react with your acid, there is a formation of again the acid is there with water and NH2 is there. Second, phosphorus to the nitric acid, phosphoric acid, and the water and nitrogen dioxide is there. Means the non-metal reacts with an acid and formation of the acid, water, and oxide is there. Fourth example, by the displacement. Displacement means interchanging of the radical is there. In that one, salt reacts with a less volatile acid. Again, there will be a salt. That salt having in the both cases there is the presence of a hydrogen and acid is forming HCl and HNO3. These four are the examples of the preparation. One is the synthesis, second is by the action of water, third is the oxidation of non-metal, and fourth is your biodisplacement. Next we are proceeding to the properties of the acid. For the properties, the physical properties of the journal, taste, it has a sour taste. Mineral acid like sulfuric acid, HNO3 are corrosive in nature, so it should not be tasted. Physical state, different acids having a different your state is there. One solid acid is there, that is your boric acid and oxalic acid. These are your solid acids. Under that one, we are coming the liquid acids. Liquid acids, some are volatile, some are non-volatile. Under the non-volatile, only one example is there, that is your sulfuric acid. These acids have a corrosive effect on the skin. It stains the skin black in some cases, yellow in other one, and amber color in another one. Different acids with the different your color or the staining is there. Next, indicators. Indicators. Earlier we have done this one. Litmus.
With the acidic, it gives the blue to red. With methyl orange, orange to pink. Phenolphthalein remains colorless. It is a very important part, and underline it and mark it important. Carbonic acid is a weak mineral acid. It turns blue litmus pink. It is non-corrosive and so used in soft drinks. Chemical properties. Under the chemical properties, reaction with the active metal first of all is here. Metal, active metals, we are taking here the example magnesium, zinc and iron. Treating with the different types of the acids and there is a formation of the salt and hydrogen. Always remember when the metal, active metal reacts with the acid, salt and hydrogen gas is forming which burn with the blue flame and gives the pop sound. Second, reaction with the bases, that is the neutralization is there. Under this neutralization, we are taking the basic oxides or hydroxides. Oxide means oxygen, hydroxide means OH. React with the acid, there is a formation of the salt and water is there. Third, reaction with the carbonates and bicarbonates. Whenever the carbonates and bicarbonates react with the acid, then there will be a formation of salt, water, and your carbon dioxide. Carbon dioxide gives your colorless effervescence and turns lime water milky. Next, reaction with the sulfides or bisulfides. Whenever the sulfides and bisulfides react with the HCl or any acid, there will be a formation of your salt, water and sulfur dioxide. Remember that the sulfur dioxide and your carbon dioxide having the same test, they turns lime water milky. Reaction with the sulfides. Now your ZNS or the metal sulfide react with your acid. There will be a formation of salt and hydrogen sulfide. Hydrogen sulfide gives the rotten egg smell, that is a test of H2S. Reaction with fluorides. That reactions you already done in your what? The different preparations. Sodium chloride reacts with the sulfuric acid. Temperature we have to consider because if the temperature is below 200 degrees Celsius, there will be a formation of your bisulfates. And when the temperature is above the 200 degrees Celsius or equal to, then it is the sulfates. Reaction with the nitrate, very, very important reaction. Your lead nitrate react with the hydrochloric acid. There will be a formation of the lead chloride with the nitric acid, and again the lead nitrate reacts with the sulfuric acid, lead sulfates are forming. Here again the same reaction is coming, and but the temperature consideration is always there. If it is below 200 degrees Celsius, then the sulfates are forming, and if it is above the 200 degrees Celsius, then your if it is below 200 degrees Celsius, then the bisulfates are forming, and if it is above the 200 degrees Celsius, then the sulfates are forming with the different types of acid. Now the last topic of the acid, that is the uses. Different acid having a different use, and this table is very, very important, students. Kindly learn it thoroughly. One more question can be there in your exam. Coming to the your now index question, that is your homework part. Kindly go through all the topic of the acids, read it properly, learn it properly, practice all the reaction by writing, and after that start doing the in-text questions. If any doubt is there regarding that questions, kindly give me the message. I will clear your doubts in the next meeting. Thank you and God bless you all.